Hi, let's talk about decibel. What is it, how do we use it, and why is it important? So this is part of the wireless or SIGINT series that I'm creating. Watch other videos to become familiar about why this is important and how we're using it for other applications. Today we're just going to be talking about a baseline knowledge of what decibel is, why is it important, and why is it a tool in electronic warfare or wireless hacking toolbox. So on the left are some very simple, straightforward rules. If you're working with decibel at all on any of the tests, specifically CCNP, which is Cisco's intermediate certification between CCNA and CCIE, then memorize this, write it down. What this is saying is if the two antenna sources, so if the source and the reference are equal, then you'll have 0 decibel change between the two. If one has twice the amount of power, then essentially the conversion is you add 3 decibels. If it is less than half the power or exactly less than half the power, then you subtract 3 decibels. If it's 10 times the amount of power, then you add 10 decibels. And if you divide the amount of power by 10, then you subtract 10 decibels. How do we come up with this formula? On certain exam questions and in the real world, when you're looking at hacking with your own tools, using aircrack and leveraging custom Metasploit modules, you may need to calculate the power change or milliwatt difference or the change in decibels. So in this scenario, we're working with decibels or dB, and it's saying 10 times the log base 10 of your target or your source that you're looking at subtracted by log 10 of the reference antenna is going to be equal to your decibel amount. However, if you're working with logarithms, there's a special property within logarithms that if you subtract one log from another, assuming the same base, then you could actually use the formula log of that base from the first divided by the subtracted value, or in this case P2 divided by P1. Take the logarithm with base 10 of that and then times it by 10, you'll get your decibel. We'll go through many examples throughout the next couple weeks. Today I want to touch upon 2 simple examples looking at converting from one reference antenna to another. Also looking at how you can calculate the different decibel and megawatt value based on simple rules of decibels or simple power change rules. So let's erase this and let's go into our examples. I'm going to keep up the left side, however the right side I'm going to erase. If you want to copy it down really quick, go ahead, pause this video, take a few minutes. But we can't work on the board while that's there. So in the CCNP, specifically in the wireless section, it goes over how to calculate reference antennas and how to calculate the change from one antenna to another. In this scenario, we're going to use that very same section to calculate and follow the format that Cisco provided, but obviously we're going to use our own numbers and we're going to use our own calculations, so there's no issues there. What this is saying is that's antenna A. Antenna B. And antenna C. So in this scenario, I just picked random numbers. You can pick any number you want for these different antennas. So for antenna A, you have 10 milliwatts. and then you have 1,000 milliwatts, and then you have 2,000 milliwatts. Obviously, you can change these identifiers at the end. However, I'm leaving them as milliwatts just to make sure it's not confusing at all. So in this scenario, we're going to have B minus A. We're going to have B divided by A. And then we're going to talk about in decibel. And we're going to use the simple rules of power changes associated with decimal values. We're also going to use the formula to calculate this. So in this scenario, if you're subtracting different milliwatt values to get the milliwatt difference between one reference antenna to another, it's simple. You do 1,000 minus 10, and that's 990 milliwatts. Now, if you divide it instead of subtracting, then what you have is essentially 100 times more power for antenna B than antenna A. Because 1,000 divided by 10 is going to be 100. In this scenario, let's use the simple rules of decibel values. So if we're looking at 100, that would be times 10 times 10 twice. So essentially what you would do is you do A plus 10 equals A plus 20 decibels. If you're using the formula, you have 10 log base 10, 1,000 divided by 10. So in this scenario, you can cross out one of the zeros. So essentially you're looking at 100 log base 10, or the log base 10 of 100. And then you times that by 10. So what you're going to get is 20 decibels, which is what we got in our simple rules formula, or simple rules of power changes for decibel values. And just to spell it out here and show some of the end users how it works is when you take a log base 10, when you take the log of 10 with a log base of 10, then essentially that's just equal to 1. And so in this scenario, we're having 100 log base 10, or log base 10 of 100, which will equal 2. 2 times 10 will equal your 20, which is the same that we found when using the simple rules of power changes for decimal values. So let's go through the second example. Second part of this example. We have one more example after this. But now we're concerned about B and C. So we're going to look at C minus B. We're going to look at C divided by B. We're going to look at in decibel for C. And then we're going to look at in decibel for C with the formula. So in this scenario, if you subtract the two different antennas, then you'll get 1,000, because 2,000 minus 1,000 is 1,000. Difference. In this scenario, when you take C divided by B, you essentially get 2 times the amount of B, because 1,000 times 2 is going to be your 2,000 reference. When you're looking at decibels, we can easily see that it's going to be 2 times the amount, so it's just going to be plus 3 decibels. So it's going to be B plus 3 decibels. And when we're using the formula, now we do 10 log base 10 times 2,000 divided by 1,000. Remember, that's just really equal to 2. And when you take log base 10 of 2 times 10, you're going to equal 3, or you're going to get 3. So essentially we found, using the formula and the simple rules of power changes for decimal values, that the difference between antenna C compared to antenna B is just going to be twice the amount in milliwatts, but it's also going to be, you add 3 decibels for antenna C. We found that using both the simple power rule changes, and we found that using the formula. Now let's go through one more example, and this is going to be the last one for today. And then we'll go through how to calculate end-to-end decimal values for the antenna using both the reference antenna for, I guess, the hacker's setup, and then calculate the net loss associated with the entire end-to-end communication stream. But we'll also talking about the net loss associated with the feed going to the antenna. We'll talk about the gain associated with the antenna. We'll talk about the free space propagation loss, which is actually a little difficult to calculate and probably won't be used in most of your certifications or in your courses. Cisco actually says don't use the free space propagation formula because it's a little too complex. And then we'll talk about the enterprises side of it and how you calculate the antenna gain, how you calculate the difference or the loss in the feed going to the system, and then we'll talk about calculating the system's power as well. So in this scenario, let's talk about 2 more antennas. Once again, this is following the CCNP's material, but we're using different numbers to essentially make sure we don't have any copyright issues. Here's D, antenna D, and then antenna E. So in this scenario, I just picked random numbers, and it was pretty interesting to work with this. So we want to find in milliwatts the energy associated with it. We also want to find in decibels the energy associated with it. And so for the first one, we can see that when you're looking at a simple formula for the power change, for 100 milliwatts, you can times 10 and then divide by 2. That's probably the easiest way to get 50. So you'd use D times 2, times 10 divided by 2. And then for decibels, we just take the values that we used and use the rules associated with the decibel change for that antenna. And we say D minus 10 plus, I apologize, D plus 10 minus 3 decibels. And that will equal D plus 7 decibels. And so those are the 2 examples we went through. We'll be going through more advanced examples moving into the future. I'll be covering everything associated with the wireless sections within CCNP's core enterprise certification. I'll also be covering different aspects associated with EC Council, how to use your own antennas or your own SDRs, which are software-defined radios such as RF Hack, AirSpy, other things like that, to then hack ZB, gateway or hack different wireless devices. Not going to teach you how to hack GPS. And everything that I'm teaching needs to be used responsibly. So I thank you for your time. I hope you have a great day, and I hope you watch, like, and subscribe in the future. Have a great day. Bye.